Hello students, today I thought I'd work with you on perimeter and circumference of different shapes, just to work through the basics to make sure that we're all on the same page moving forward. So when we talk about perimeter, we're talking about the distance around a given object that is calculated by finding the sum of all sides. So what's really going to be important in this unit and any unit moving forward, but specifically with measurement, is that we really want to make sure that we're using the formulas provided. The formulas are critical, and we want to make sure we remember them and use them, because there's little pieces and nuances in each that if we miss a step, it's going to cause some problems for you. So to calculate the perimeter of a regular polygon, you determine the measurement of one side, then multiply this measurement by the number of sides in the polygon to determine the perimeter of the polygon. So for example, if I had a square, and I just draw a quick square here, and it's irregular because it is regular because all the sides are equal to one another. Let's say this is 5 centimeters. That means all sides are 5. So what I can do is I can do P equals sum of all sides, which would be 5 centimeters plus 5 centimeters plus 5 centimeters plus 5 centimeters, which would give us 20 centimeters. And it's just centimeters, not centimeters squared. What we could also do, because it's a regular one, P equals 4s. So in other words, 4 times the side. So P equals 4 times, in brackets, 5 centimeters. And that would give us the 20. So you can do either format, but just understand that when it is regular and that word is used, it means that the polygon has equivalency all the way around. So if we look at calculating the perimeter of the following polygons, we have a rectangle here. And if we look at the hash marks, and this is a really important aspect as well when we're looking at the hash marks, and I'll just change to this here, that if it's 6 here, it's going to be 6 here. And if it's 4 here, it's 4 here. So I would again make sure that I write it as P equals sum of all sides. And that would be 4 centimeters plus 4 centimeters, because there's 2 of them, plus 6 centimeters plus 6 centimeters. And that will give me a total of 20 centimeters. Now, if we look at this next shape right here, you'll notice that we have 3 hash marks, 1, 2, and 3. And that would signify the fact that we're dealing with an equilateral triangle. So if we were to go to write this, we could do P equals sum of all sides. And it would be 23 centimeters plus 23 centimeters plus 23 centimeters, which will give us 69 centimeters. The other option here would be to do P equals 3s, because we know the side length is 23. And you're going to see here that we would get the same answer. So if it's regular, like we had in the previous with the square, we can multiply instead of add. Just be careful. Sometimes I have found that students might make a mistake and misidentify something, so sometimes it's better to just write out each section. It might take up a little more space, but that's okay. This shape here is irregular, but the measurements are all on, except for this one right here. And we know, though, that it is 4 because there's a hash mark above. So that is 4 centimeters. One of the things that I like to do is to go on and actually label these things so that I know what I'm working with. And that way I've got all the pieces that I need. So this one's going to be a bit longer, but we'll start it out. P equals sum of all sides. And so if we start, we have 10, so 10 centimeters, and I go clockwise, plus 5 centimeters, plus 4 centimeters, plus 3 centimeters. You'll notice that I keep putting the units in, plus 6 centimeters, plus 4 centimeters, plus 13 centimeters. And the reason I put the units is I don't want to forget that at the end. The units are very, very important. There's a huge difference between, say, 25 centimeters and 25 meters. And so we want to make sure we have the right units in place at all times. So if I go through this quickly, we have 10 plus 5 is 15, plus 4 is 19, plus 3 is 22, plus 6 is 28, plus 4 is 32, plus 13, that will give us 45 centimeters. Okay, now this brings us to our next little nuance, and this is the concept of pi. So pi is an interesting mathematical concept that's been around for thousands of years. So if you measure the distance around a circle, which is called the circumference, and divide it by the distance around the circle, through the center, you will always come close to an approximate value of 3.14 and then this extremely long number. We use the Greek letter pi, pronounced pi, to represent this value. The number goes on forever. However, for our calculations, we'll round pi to 3.14. On your calculator, if you press the pi button, it will be it'll go longer, and therefore an answer used with the calculator button versus typing in 3.14 will be a little bit different, but not enough that it will have a big difference in what we're doing. I'm more looking at the process. In a perfect world, you're using the calculator to do it for the simple fact that we want it as precise as we can be, okay? So to calculate circumference, what we're going to need is diameter. So the distance across the circle through the center is called the diameter. When given the diameter of a circle, you can find the circumference by using a simple formula, and you can see that here. Circumference equals pi times diameter, and we simplify it as C equals pi d. Okay? So using the formula provided, find the circumference of the following. So in this instance, we have 12, so C equals pi d. So C equals, I'll put pi, and then, because I'm going to use my calculator or my phone beside me right now, and 12 centimeters. And when I calculate that out, we end up with sorry for the wait there. We end up with 37 and 7/10. Always round, so I'll put this up top, always. Oops, a little messy there. You know from every aspect that we do in class, we always round to the nearest hundredth. And the reason we do that, as you'll remember from classes, that's to the nearest penny. So we want that. And remember, I know that money is rounded when you get cash at a store or you're given change, but a bank won't. A bank's going to want every single penny they can get out of you. So you need to get used to being as precise with your calculations as you can. So if you look at this next one here, we have 18 centimeters. So if we do circumference equals pi d, it would be C equals. Notice I'm also lining up my equal signs and writing the formula out and doing the pieces. I would like you to do the same. Pi in brackets 18 centimeters. Okay, and circumference equals, and we'll just calculate this out here. So, and when rounded, I get 56 and 55 hundredths of a centimeters. Okay, and last but not least, we're going to work with 26.6. And a lot of times with measurements, you are going to notice they need to be extremely precise. And so I'm not surprised we got some decimals in this one. So C equals pi d. C equals pi bracket 22 and 6 tenths. I should say it the way I taught you. And that will give us, so that gives us, actually when rounded, will give us 71 even, 71.0 centimeters. Okay, so that's when using pi. So remember that pi, if you're not using the calculator, pi is equal to 3 14/100. Okay, but also that the diameter is given. Now, this isn't always the case because sometimes you'll get radius, and we'll talk about that in a moment. So in this instance, it says the diameter of a CD is 11 centimeters. What is the circumference? So we would start with our formula. C equals pi d. C equals pi times 11 centimeters. And that will give us 34 and 56 hundredths. Okay. The second one, the diameter of this coin is 10 millimeters. What is the circumference? So kind of the similar situation, C equals pi d. Now, you might be tempted because you're multiplying by 10 just to do it in your head. I'm going to encourage you and challenge you not to do that for the simple fact that you will get more complex numbers and you're going to need to use the formula as much as possible. So I would still write it out. It won't take that much time and it's going to be more effective for you. So we end up with pi times 10, and that will give us 31 and 42 hundredths centimeters. Okay. Now, sometimes we will encounter a radius. Now, a radius, as you can see here, is a line that extends from the center of a circle to the outer edge. And great way to identify the radius is always just to highlight it. And you can see here we've got the radius there. To figure that out, to figure out the diameter, we would just double the radius. So diameter equals 2r. So in these calculations here, for this circle, in this one with 4 centimeters, we really need to double it. So what I'm going to do here, and I can just do it over on the side if I want, d equals 2r, d equals 2 times 4 centimeters, d equals 8 centimeters. So what I would do in this situation is I would then extend this and I would say the red all the way across is going to be 8 centimeters because now I know what to use. So if I do C equals pi d, C equals pi times 8 centimeters. And this is also a good thing to do too in terms of the reasonableness of your calculations. I know we've spoken about this a lot in class. One of the key things is to think, all right, well, I know it's 3.14, and I know that I'm going to have some decimals involved, but 8 times 3 is 24. So my number is going to be a little bit more than 24, but it shouldn't be that much more. So let's see what it comes out. And in this instance, I get 25 and 13 hundredths centimeters. So I was close. And that's using that mental reasonableness calculator. Like, is this going to give me what I'm looking for? This next one, if we go and have a look here, we have a radius of 2.2 centimeters. So I'm going to come to the side and D equals, do this one, and we'll go back to black, I think. So D equals 2R, and I don't even need to put it in brackets here, so I'm going to change that up too. D equals 2 times 2 and 2 tenths. And D equals, this will end up being 4 and 4 tenths centimeters. Okay, so what I can do is I can add that in, and I can just draw, and I know that the blue is going to be 4 and 4 tenths centimeters. Okay, so C equals pi D. C equals pi times 4 and 4 tenths centimeters. And when I calculate that out, I come out with 13 and 82 hundredths centimeters. Last but not least, we have the 7 here. And again, I'm going to highlight it. I like to identify what I'm working with. Okay, so 7 centimeters. I need to go ahead and I need to double that. So diameter equals 2 times the radius. Diameter equals 2 times 7 centimeters. Diameter equals, so it's going to be 14 centimeters. And I can put that in, and I can just identify that. Now the whole thing's going to be 14. So C equals pi times diameter. C equals pi times 14 centimeters. C equals, and if we double check that quickly, we get pi times 14. And I end up with 43 and 98 hundredths centimeters. So 43 and 98 hundredths centimeters. And again, I know 14 times 3 is 42, so it made sense that it would be in that range. That's the number I'd be coming out with. Okay? So if we look at this situation, the radius of this pizza is 2 inches. What is the diameter? So you'll notice we need the diameter quickly. So we would just do D equals 2R. Diameter equals 2 times 2 inches. Diameter equals 4 inches. Radius of wheel is 4 inches. What is the diameter? We would do the same thing. Diameter equals 2R. Diameter equals 2 times 4 inches. Diameter equals 8 inches. Okay. So this is an interesting question because we might go a different way. It says the circumference of this pizza is 22.5 centimeters. What is the diameter? What is the radius? So let's start with the circumference formula. So we know that C equals pi times diameter. So let's go with what we know. We know the circumference is 22.5 centimeters. We know what pi is, but we don't know D. So in pi, I can rewrite this a little bit differently. Okay, I can do 3.14 times the diameter. So the question is, how do I get rid of, okay, I need to get rid of something that's being multiplied. So I can rewrite this again in a way that might be easier for everybody. So if I do 22.5 centimeters equals 3.14 D. When you think back to your algebra unit, measurement formulas are really just like algebra. We're just going to rearrange the equation here. If I want D by itself, the diameter by itself, I have to get rid of the 3.14. So how would I do that? Well, if it's being multiplied by 3.14, I can divide by 3.14. So I'm going to write my next line here and identify it. So I would put 3.14 diameter divided by 3.14. What I do to one side of the equation, as you know, we do to the other. Now, we know from our regular work that these will cancel. And we know that our final answer here will be the diameter is the equivalent of what, 22 and a half divided by 3.14. And that will give us 7 and 17/100 centimeters. Now, that's the diameter. How would I get the radius? Well, radius equals diameter divided by 2. I don't know the radius, but I know the diameter. It's 7 and 17/100 centimeters divided by 2. The radius is, and we do that here, we get 3 and 58/100 centimeters. So perhaps the most important thing on this page will be this, and it's that the radius is the diameter divided by 2. So just make sure you have that in the back of your mind. But you'll notice that I started with a formula we knew. I started with this formula here. I started with circumference equals pi times diameter, and I used my algebra skills to actually rearrange the equation to get me where I want it to be. Okay? Now, these complex shapes are ones that we can work on, and we'll take care of the first one in yellow. The issue that we're going to have is up here. And if I just draw a line across, and we'll change that up just for a sec, is right here. So the question is, what is the diameter of this? And it's pretty easy to break down. You'll notice that we have 6 centimeters here and 16 here. So if it's 6, this has to, here, the rest of it has to be 10 to make the 16. So this is 10 centimeters. Oops. And now I have the pieces I need. So let's go ahead and break this one down for a moment. And if you notice too, this here is 7 centimeters. This will be 7 as well. So the only thing I need to know is the circumference around the outer edge of this circle here. And we don't really know what that is yet. So what we're going to have to do is find the circumference, but it's a semicircle. So then we're going to have to divide by 2. So let's do that first. Circumference equals pi d, but it's a semicircle. So we're going to divide by 2. Circumference equals pi times diameter. Diameter is 10 centimeters. And we're going to divide by 2. Circumference equals, so pi times 10, we get 31 and 42/100 centimeters, and we're going to divide that by 2. That gives us 15 and 71/100 centimeters. So now we knew that the main key thing here is that number is what we're going to apply in. We're not going to use the 10. We needed it for what, to calculate the diameter, but we're not going to use the 10 because we're really looking at this measurement here around the outside. So let's pull out what we need, and we know that P equals sum of all sides. Notice that I start with the formula again. P equals, well, I'm going to go clockwise. I know that from here to here is 15 and 71 centimeters, 71/100 centimeters, so 15 and 71/100 centimeters. Plus, we've got 6, then 7, plus 6 centimeters, plus 7 centimeters, plus we've got the 16 centimeters, plus 7 centimeters. So when we add that all up, we end up with, 15 and 71/100 plus, that'll be 6 plus 7 is 13, plus 16, plus another 7. I've got 51 and 71/100 centimeters. Now I'm going to double check that again, just because I've got a lot of numbers. So I always double check it, students, just to be safe. I make mistakes too, and it's very easy to make a mistake and not key something in. but I double checked it there and we're good. So that would be it. If I was to attempt this other question here, this would the only difference would be we've got measurements of 4. We've got 4 here and here. We're missing a measurement here. So probably another 2 in there to make that a total of 6, because if it's 4 from there to there, it's kind of tough to tell. This we would have to divide by 4. We'd find the circumference and divide by 4. But that's just an overview of how to calculate perimeter, how to calculate circumference. Why do you focus on those? Well, what if you're putting a fence up around your yard? You need to know the perimeter and what you're going to need to purchase. You need to know the lengths. You don't want to overpay and you don't want to underbuy. So you want to have the right materials to do your job. The circumference around the outside of something could be for packaging. There's a lot of applications in the real world, and hopefully this helps you identify more of them.